Now that determinant is defined, the useful properties fall out. This is where the formula starts paying rent instead of just looking scary. We first get column operation rules, then the upper triangular shortcut, then a 3x3 computation that does not require emotional support. Because determinant is multilinear in the columns, scaling one column scales the determinant by the same scalar. Because determinant is alternating, swapping two columns changes the sign, and equal columns force determinant 0. The most useful move is column replacement. Add a multiple of one column to another, and the determinant does not change. A rare bargain in mathematics. The proof is exactly one line of multilinearity and one line of alternation. The extra term has two equal columns, so it dies. Efficient, almost suspiciously so. If the columns are linearly dependent, one column is a linear combination of the others. Expand in that column, and every resulting determinant has repeated columns. So the determinant is 0. Geometrically, the supposed volume has collapsed into a lower dimensional pancake. Delicious, but not n-dimensional. For an upper triangular matrix, entries below the diagonal are 0. In the permutation formula, almost every term walks straight into one of those zeros. A non-zero term would need sigma of j less than or equal to j for every column j. The only permutation that can do that is the identity. So only the diagonal product survives. The rest of the permutation formula quietly falls into a pit, which is honestly its best use case. The practical method is row reduction. In this example, we only add multiples of one row to another, so the determinant does not change. Once the matrix is upper triangular, the shortcut says, multiply the diagonal, an actual computation method. Finally, we were so brave. Now compute the determinant of this 3x3 matrix, not by expanding 6 terms. Because apparently we still respect our remaining lifespan. First, eliminate the entries below the first pivot. Replace row 2 by row 2 minus 2 row 1, and row 3 by row 3 minus row 1. Both are row replacements, so the determinant is unchanged. The matrix is already looking less like a spreadsheet having a panic attack. Now replace row 3 by row 3 plus 2 row 2. Again, this is determinant neutral, no hidden tax. For once. The result is upper triangular, so the determinant is the product of the diagonal entries. 1 times 1 times 3, which is 3. So determinant is 3. The permutation formula defined it cleanly. Row reduction computed it efficiently. Imagine using tools for their intended purpose. Wild concept. That is the pipeline. Definition gives column rules. Triangular matrices give diagonal products. And row reduction turns examples into something survivable. Next, we can justify the full row operation machinery through multiplicativity and elementary matrices. Yes, more proof. The universe remains unreasonable.